So for slope and y-intercept, I'm going to start off by having us just graphing a couple of different lines. So let's say that y equals 2x. That means for every value of x, I'm going to say times 2 is my y value. So if I picked a couple, if I said x is 1, if I said x is 2, and then I said x is, let's say, 0. Okay, 1 times 2 is 2. Boom. Next one, 2 times 2 is 4. Finally, 0 times 2 is 0. Alrighty, so let's graph those points. Let's say that 1 and 2, 1 comma 2 is right there, 2 comma 4 is right here, and then 0 comma 0 is right here. So we're going to call that our first line. Okay, let's do another one. Let me pick a different color here, hold on. Let's do red. Okay, let's do y equals 3x. So every time I have an x value times 3 is my y value. So let's do that again. Let's do let's pick some different numbers. Let's do 0 again though, and let's do 1. Let's pick the same numbers, 1, and then let's also do 2. Okay. If I plug in 0, 0 times 3 is 0. Now for 1 times 3 is 3, and for 2 times 3 is 6. Let's graph that. 0 and 0, same spot right there. Now 1 and 3, over 1, up 3. Uh-oh. Now 2 and 6, over 2, up 6, puts me a little above my line, my plane, so it's right there. But I can make that line, and I think you get the point. What about if I said one more? Let's pick one more in a different color for that. Let's do blue. What if I said y equals x? Meaning every value of x is the same as y. So if I said 0, well, the same value would be 0. If I said 1, the same value would be 1. And then if I said 2, the same value would be 2. So let's do that. 0, 0 is right there. 1 and 1 is right there. And 2 and 2 is right there. Let's do these. Oops. Well, I think you get the point. I have 3 different lines that look like that. Red, white, and blue. What you notice here is that I have 3 different lines. Each of those is tilted slightly different, as in it leans further one way or it goes more on the straight up and down path. This one leans more to the right, right? Those are all slopes. The slope describes that ratio of that tilt, meaning like the rise over the run, and that'll make more sense in a second. But the ratio determines how sloped or how slanted, maybe you understand it that way, that is. So there's a very simple formula for determining the slope of lines. The slope is the vertical change over the horizontal change, or more simply, the rise over the run. When you think about rise, that's how far it goes up. Right? How it rises and how it runs is going that way. Okay, let's try applying that a little bit. So here we have a picture of a line. We're going to determine what the slope is of that line. So like I said, rise over run. Since we in English read from left to right, we would say that this point is our up. That's a positive slope, right? From left to right, it went up. Think about it like skiing. You're skiing up. If it were to go down, we'd call that a negative slope. We'd be going down, and a negative direction is down. Like with money, we always go up, that's a rise. We go down, that's a fall. That's negative. Okay, as we go from left to right, this from the point 2 to 4, because remember, up and down, those are our y values. And every graph, our left and right is our x, our up and down is our y. So when we talk about our rise, we went from 2 to 4. That is a change of positive 2. So I'll write that right here. We went plus 2 as our rise, correct? So we'll call that our r. Now, oh, that doesn't make much sense. Let's call that our, I guess I'll just write rise. And that is plus 2. Now for our run, again, run, we went left to right. We went from -6 to -2. That means we moved how many spaces? It's 4. So we say we ran positive 4 spaces, okay? Now, rise over run means, let's do this. Rise was 2 over my run was 4. That's it. That's the slope of this line. Now, of course, we simplify. We say it's 1/2. What that means is that for every space I go up 1, I will go over 2. So let's try that. Let's see if this makes sense. If I go up 1 space, I go over 1, 2. Look at that. I hit the line again, didn't I? So that works. I go up 1, I go over 2, and boom, I hit the line again. Let's try this one more time, even though the point's not shown. If I go up 1 and over 2, there it is on the line. If I went down 1 and back 2, meaning like I started here, I hit the line every time. That means the slope of this line is up 1 over 2, or the rise and the run is 1/2. That's the slope of this line is 1/2. So let's try that again. Rise over run, right? Rise over run. Well, our rise, we go from left to right, correct? Our rise, actually, as we read from left to right, went down, didn't it? We have a negative slope. It went down from 4 to 1. That's a downward slope of 3 spaces. So since it went down 3 spaces, I'm going to write that as down. That's -3. Okay, my rise, although it sounds funny because rise, you think about moving up, but my rise could be negative rise. It went down 3 spaces. Now, I talk about my run. As I move from left to right, I moved from +3 to +5. That is a run of 2 spaces. So I ran 2 spaces. So I rose -3 and I ran +2. That means the slope of this line is actually -3/2. That can be written also as just -3 over 2. Another way we can look at that is to say that our rise is our difference in our y coordinates, and our run is our difference in our x coordinates. Meaning, our y2 minus y1 over x2 minus x1. Now that should look kind of familiar. Now let's think about that though. Let's apply that and see if that's true. y2, so our second y value is 1, minus our first y value was 4. Our second our second x value was 5, minus our second x value was 3. Well, 1 minus 4 is -3. 5 minus 3 is 2, so we still get -3/2. Again, that might look kind of familiar in some way. But notice, I didn't do negative and a negative in there, and it wouldn't work in that case, but if you made a negative and negative, then you'd have a positive, and which would mean that line is actually going this way, which means you read it from right to left. So to figure out the slope, what if I just gave you 2 points? Like I said, we have our x1 and our y1, and we have our x2 and our y2. I said, what do you need to do that? You should say y2 minus y1 over x2 minus x1. Let's plug those in. y2 was 3 minus y1 is 6. So we have that and we have that. All right. Then we do 4 minus, and don't forget the negative sign. I know that's a big favorite of your group. But 4 minus -2. Okay. 3 minus 6 is -3. 4 minus -2 is 6. So we should have -3/6, which simplifies to -1/2. So the slope of these 2 points is -1/2. I'm going to throw back to a couple of old concepts with dividing and 0 that you might remember. If I said 0 divided by any number, let's say 0 divided by 2, what is that? Is that 0, 2, or undefined? 0 divided by any number is 0. Okay, now what if I said any number divided by 0? Let's say 5 divided by 0. Is that 0, 5, or undefined? That's actually undefined. Remember, you cannot divide by 0. And I'm going to show you why that makes sense now. So let's say I have my coordinate plane right here. And I'm going to say 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Finally, 1, 2, 3, 4, 5. And this is our x, and this is our y. Okay, let's do this first one right here. On the top, if I said the slope was 0, what I mean by that is that every time I have a value for x, it's always 0. My y value is always 2. What that looks like is like this. That means 2, but I don't change my slope. For the bottom one, it's like this. 5, 0 would look like that. I'll show you why. Hold on. So I'm going to put 2 points on this line right here. I'm going to put the point here and point here. I'm also going to put points on this one. I'm going to put them right here and right here. Now, what I said before about the slope, right? Let's do this. I said it's the y2 minus y1. Well, let's call this point right here 2, 2. This point over here is -1 and 2. This point up here is, let's see, that is 5, 4. And the one down here is 5, -1. Okay. For our 0, which is this one right here, y2 minus y1, well, that's these numbers right here. So I have 2 minus 2 over 2 minus -1. 2 minus 2 is 0. 2 minus -1 is 3. That's 0 divided by 3. Remember, 0 divided by any number is 0. Look at this line. If you look at this line, if I asked you what is the slope, you'd say it does not have a slope. It does not change. It's just flat. There is a 0 slope. So there it is. 0 is 0 slope. If I did it again, but now with this vertical line over here, remember I talked about in the other video about the vertical line test and how it's not a function? So let's look at this one. y2 and y1. Well, which one do you call the second and which one do you call the first? If I read from left to right, I don't know which one to call the first or which one to call the second. But it doesn't matter. I'll pick one. Let's do the bottom one is the second, and the top one is the first. So let's do -1 minus 4. And on the bottom, we would write 5 minus 5. -1 minus 4 is -5. Divided by 5 minus 5 is 0. Anything divided by 0 is undefined. Now let's think about it. Look at this line right here. If you were to say, what is the slope of it? What would you say? Does it have a slope? It goes straight up and down. It's vertical. And I told you the vertical line test means it does not have a slope. It is not a line that we can do, call it a linear equation. It's all starting to come a little around in a circle here, isn't it? Starting to feel a little related? One final thing we need to know before we end this video is the y-intercept. The y-intercept of the line is the point where the line crosses the y-axis. So look at this line right here. This is our y-axis. What point does this line cross this line? You would be able to say that since this doesn't move, it's 1, 2, 3. That means that our y-intercept is the point 3. That is the point, basically, we're saying on the y-axis. That is 3. So for that equation for this line, we know we're going to go ahead and just say it's plus 3. We're writing the equation of this line. Y equals something, then plus 3. Okay, that plus 3, this part at the end is always our y-intercept. Now quickly, let's look at our rise over our run. On this line, we know that our rise is -2. It says it, okay? That means as we move from left to right, we went down 2 spaces. So we can say it's -2 over something. And as we move from left to right, we went from 0 to 4, which is 4 spaces. So we can say over 4. Let's simplify that. -2 over 4, meaning it went down 2 spaces and over to the right. 4 is -1/2. So I would say this is -1/2 x plus 3. If you look at it, what I mean is if I went down 1 space and over 2 spaces, there it is again. Down 1 space over 2 spaces, there it is again. But it started at the point 3. If you look at this right here, that's called slope-intercept form. Slope-intercept form is this. Y equals mx plus b. M is our slope. B is our y, that's a y, intercept. X and y, that's our x and our y values. So we have our x, that's our x value, or in this case our inputs, and y, which is our y value, which is also our output.